Hello again, fellow math lovers and math contest enthusiasts. We're going to pick up right where we left off with the 2013 Cimc paper, and we're just going to take a look. We just started, or we're just about to start, Part B, which is the portion where we need written answers, justification, all that fun stuff. So, question number 1. The points -5, 0, -5, 7, -1, 7, and -1, 3 are graphed as shown. Okay, there they are. The line L has equation x equals 3. So let's write down all the coordinates on L will have x equals 3. So straight up and down, parallel to the y-axis. And point Q is the reflection of point C in L. Okay. Point P is the reflection of point D in L. Point R is the reflection point of point B in L. So and S is the reflection of A in L. State the coordinates of P, R, and S. Okay. So to be a reflection, it's just got to sort of be a mirror image. Now, fortunately, L is just parallel to the y-axis. So basically, all we'll be doing is counting the distance from, if we wanted to reflect D, we count the distance from D to L, and we go that much further, but on the other side. Okay, we can test that out with Q. All right. So to reflect in the line, x equals 3. We have to determine the distance A, B, and D and then move that far, but on the right side. What was C? C was -1, 7. So how far away is he? So x equals 3. We need to add 4 to it. The height will remain the same. So Q should be at 7, 7. Let's just double check. Q is, in fact, at 7, 7. 1, 2, 3, 4, 5, 6, 7 all the way up here, and then 1, 2, 3, 4, 5, 6, 7 all the way up here. So we just need to do the same with A, B, and D. So A is -5, 0, B is -5, 7, and D is -1, 4. Okay. So P, I think, is the name of his reflection point. So he should be 11, 0. Let's just double check that that's the name of his reflection point. S is the reflection point of A, P is D, and R is B. Okay. So we'll just go back and change that. Just so our answers are absolutely correct. All right. So now B's at negative 5, 7. So he's also going to be distance 8 from L. And so its reflection is also going to be distance 8 from L. But now it's on the right. So R is at, and it'll be 3 plus 8, and the height remains the same. We did see. What was D? D was, I think, negative 1, 4, but we'll just double check that. Yep, negative 1, 4. Okay, great. So 3 minus negative 1 is equal to 4. He's distance 4, just like C was distance 4. Seven, 4, 11, 7, and 11, 0, respectively. And that was all question A was asked. State those coordinates. We could have drawn a graph and put them on here and labeled them all nice and neat, but really not necessary. So calculate the perimeter of the figure ABCD PQRS. So we're going to have to draw this anyway. So we just need to calculate the perimeter there. So let's draw what we're looking at. I'll try and mimic the grid on the graph paper as close as I can, but I'm really not that good at that sort of thing. Alright, so what do they have? They have 5 labeled, or negative 5 labeled, 2, 3, 4, 5, and negative 10 labeled. And here's our line. You know what, we'll put the line a different color. We'll make him, I guess that's lavender. Just a horrible line there. Absolutely awful. Way too thick, and it's just jutting out at weird angles. This is why I try not to use the graph paper very often. I just make an ugly mess of it. Alright, so back to sort of labeling our graph a little bit. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. Nothing was higher than 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. So negative 5, 0. That was A. And negative 5, 7. That's where we found B. Negative 1, 7. Where we found C, and negative 1. I wish the computer would stop jiggling the pen for meaning I want to change color. Put D right there. Now, where was Q? Q was at negative 7, 7. Or, sorry, 7, 7. So Q, stop it. R, and then S would be all the way down here. And there's P. So there it is. Kind of looks like a castle or something. Okay. So we know AB is equal to 7. BC equal to 4. I don't know why I'm still in blue. CD is equal to 3. PQ is equal to 3. QR is equal to 4. RS is equal to 7. AS is equal to, okay, so we're going from negative 5 up to 11. And DP is equal to, so we're going 7 minus negative 1, 8. I want my black pen back. You know, if you draw a nice, neat, clean graph like this, you can just say by inspection. You don't need to do all the coordinate calculations. 7 plus 4 plus 3 plus 3 plus 4 plus 7 plus 16 plus 8. Have we missed any? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 lines, and we have 8 things here, so 7 plus 4 plus 3 plus 4 plus 3 plus 7 plus 16 plus 8. We can do that on a calculator. We can group these, like these guys together are 24. These guys are 14. These guys are 14. But whatever we do, we get 52. And there's really no other explanation we don't need to show our coordinate subtraction to figure out these heights. It's all right there because we drew an appropriate diagram. Okay. All right. Figure ABCDPQRS is rotated around the line L to create a three-dimensional solid as shown. This solid is a larger cylinder with a smaller cylinder removed. Okay, so a small cylinder here with height DC got removed out of the center of a cylinder with height EB. And diameter AS, which we just figured out was 16. Okay. Determine the volume and the surface area of this solid. Okay. Well, the volume is going to be the easiest thing to do because we can just figure out the volume of the big cylinder, subtract off the volume from the second cylinder. The surface area is a little trickier. We'll have to figure out the surface area of the big cylinder, subtract off this little hole that was cut out, add on this the flat part from that cylinder, and add on the side, the sort of, if it was a piece of paper, it was it would be what you curl to join together. I don't have a good name for this thing. The band. That's what I'm thinking of. Band. The band part of the cylinder. Okay. Alright, and a cylinder with radius r and height h has a volume of pi r squared h and a surface area of 2 pi r squared. That's coming from the two circles, plus 2 pi r h. So that'd be the height. Because if you were to use this as a piece of paper and sort of cut along PQ and unfold it, it would just be a rectangle. A rectangle of height, or of width h, and of length, the circumference of the circle, which is 2 pi r. Okay, so let's dive into this question. We have two things to do. We have to do a volume and a surface area. So first things first, let's do the volume. Alright, so the volume is just the big cylinder minus the small cylinder. He has height AB, which we know from last time is 7. So his radius, just half of that, which is going to be 8. So the volume of the big one is AB pi r squared, so that's 7 pi 8 squared. So that's 7 times 64, 448 pi. How about the small cylinder? So the height CD, I believe, was 4, but let's just go back and double check. CD was 3. All right, fantastic. We have to check. We have to make sure you don't want to do a bad calculation. And diameter of DP, which is 8. I do remember that. So the small radius is 8 divided by 2, which is 4. So 3 pi 4 squared, and that is 3 times 16, which is 48 pi. Okay. And that gives us a total volume of 400 pi. Great, that was the easy part. Now we have to do surface area. Minus minus another top of the small cylinder. Because, well, let's take a look at the picture. That back line should be dotted. Well, we already know the radius and the height for the big one. So what is it? It's 2 pi r squared plus 2 pi r h. So 2 pi 8 squared plus 2 pi 8 7. So that's 2 times 64 plus 2 times 56. So that's 240 pi. All right, now we can do the top of the small cylinder. And that's just pi r small squared, just the circle of the small cylinder. We'll need to subtract off 2 of him, but we'll get to that in a moment. So 2 pi, the radius was 4, so 4 squared, 16 pi. All right, and the last thing we need, the surface area of the small one. Okay, so how did we know to do the surface area of the big one minus surface area of the top, plus the surface area of the small cylinder minus 2 off the top cylinders? Just by looking at the picture. We don't really need any justification other than that. We just look at the picture, we see, okay, from the big one, we removed the top cylinder. Then we added in all the surface area from the small cylinder, except its top as well. We don't need a whole lot of explanation. If you want to, you can provide a sentence for that. But all right, so the small cylinder, we need 2 p r small plus 2 p r small h small, and that's 2 pi 4 squared plus 2 pi 4 times 3, so that's 2 times 16 plus 2 times 12, that's 24, oh geez. Oh, sorry, no, that's not 24 plus 2. 2 times 16 plus 2 times 12. I don't know why my calculator didn't want to do that in the first place, but it's good that we double checked. 56. There we go, 56 pi. All right, so if we combine it with our previous results, so we had 240, that's fine. 240 pi minus 16 pi plus 56 pi minus 16 pi. So 240 minus 16 plus 56 minus 16 equals 264 pi. It's got a volume of 400 pi and a surface area of 264 pi. All right. And we checked that with C part. We're at the end, and we've done everything they asked for, volume and surface area. We wrote out pictures for explanation. We also explained a little bit of what we were doing. We used the formulas we were given, and we managed to do that. It was a nice, it started out as sort of a graphing Cartesian plane awareness question, and it turned into a rather interesting three-dimensional question. So all in all, a good question. I look forward to seeing what question number 2 has for us.